the sine graph. I'm going to kind of redo what we had already done in class, so that way you guys can watch it again, maybe get a better understanding. Continue the notes that we were working on in class, please, on Friday. Add to the graph paper. If you need to get out another piece of paper, get out another piece of paper. So, and your unit circle. As we're graphing all of these, I want you, especially the first couple, I want you to think about how the sine graph is just the movement around a circle and how the radius is affecting our sine graph. In some previous tasks, we learned that A is your amplitude, which comes from the radius of the circle. W is omega, which helps us find the period. And the period is how fast our circle is revolving, how fast we're moving around the circle. And since we're going to be working with radians, in the task we did 360 divided by omega, but in radians 360 is 2 pi divided by omega. And then K is our midline, which is y equals K, or it is also our y-intercept. So we're going to use those things as we're graphing through this. But before we do that, I want us to graph the sine graph using just our unit circle. I know this is the one we did do in class. I'm going to go through this slowly, and I'm going to talk to you about where all these special points are occurring on our circle, because we want to use those points to make quick sketches of the rest of the sine functions. Since we're working with radians, I'm going to scale my x-axis with radians, and I want to use the 4 main points that are on our, actually there's 5 main points that are on the circle. We start with 0, then we move to the top of the circle, and at the top of the circle we have pi over 2. Then we keep moving around, and then the next nice point is pi. Keep moving, we go to 3 pi over 2, and then to 2 pi. That's as far as I'm going to go for this one, because I just want you guys to see what one cycle looks like. And then we'll talk negatives in a second. So using your unit circle, go to 0 radians, and since we're looking for sine, we want to look at the y value. Please don't forget that. Y equals the sine of x, and y is sine. So y equals sine on the unit circle. So at 0, your sine is 0. At pi over 2, your sine is 1. At pi, we're back at 0. 3 pi over 2, negative 1. And at 2 pi, we're back at 0. This is the full movement around the circle. We are going up, and then we go back down all the way to the bottom of the circle, and then we go back up. Each of these represents a different point on the circle. So if we're looking at our unit circle, just a really quick unit circle over here. Here's 0, here's pi over 2, here's pi, 3 pi over 2, and 2 pi. I start at 0. Sine will always start at 0. You're at 0 height. At 0 radians, sine is 0. I go up the circle, which goes to the top, which is your radius, which is your amplitude. From the top, you start to work your way back down around the circle, and you're at the exact same height. These are the same height over here, 0 and 0. Then I'm going to continue to move down around the circle, which now is the bottom of the circle, so I'm at the bottom part of the radius. So negative 1. Let me mark each of these special points with the highlighted color. And I didn't use a different color for the start. From the bottom of the circle, we work our way back up to the top, which is also where we started. All three of those points where we started, halfway through the circle, and the end, all of those match up at the center. That is your midline. This piece right here, that's the midline. It's the middle of your circle. It is that way for every sine graph. We have our start, we have our middle, and we have our end. I'm going to erase some stuff so I have more room to show you guys some things here. Let me get rid of all those highlighted marks. You guys leave yours. You can add to yours. All right. So from our midline, we have these three main points. Your beginning, this is your start at 0, 0. And this is your end at 2 pi. It ends at 2 pi because that is your period. We'll talk about that in a second. I wanted to graph this using the unit circle first. And then if you look at the top and the bottom, actually I'm not done with that part. Let's do this middle one. And this is your middle. Look at your start, your end, and your middle. They are all on the x-axis. And the only time that's going to change is if we have a K, which is going to move your graph up and down. That's our last example. And then we have these last 2 points here. This is the top of the circle. This is the bottom of the circle. And notice how they happen in the middle. And that makes sense. Halfway through the top is the top of the circle, the radius, top of the radius. And then the bottom of the circle bottoms out halfway through the negative side of the radius. All things that we want to keep in mind. Now, I want to draw your attention back to our basic formula with the amplitude, the omega, and the midline. There is an invisible 1 in front of sine. That's your amplitude. So my amplitude is 1. And I can see that. I went up 1, down -1. There is an invisible 1 with the x. So your period is 2 pi over omega. So 2 pi over 1 is 2 pi. And look where our cycle ended. It ended at 2 pi. And then the pattern, you would just keep following it over and over and over and over and over. We'd put more points so it would be more accurate. And then there is no plus k, which makes the y-intercept 0, 0. So your midline is at y equals 0. So it ended up being the x-axis. Now I do want to graph the negative side. I will want you guys to draw at least 2 cycles. I like to see 2, 3, 4 cycles. Then it kind of gives you that practice drawing the graph. If I'm going to finish this, here's negative pi over 2. So it's the negative side. Negative pi, negative 3 pi over 2, and negative 2 pi. If I can get these points from going backwards around my unit circle. So if I go backwards, I'm going to go to -1 first. Then I'm at 0. Then I'm at +1. Then I'm back at 0. So I have the rest of my sine graph. Looking at this, I can say my domain. So just talking about some features. This graph will go on forever to the left and the right, -infinity to infinity. Your range is going to be dependent upon the radius. In this case, it's -1 to 1. Let's see, we know it's continuous. It's odd because it's symmetric to the origin. All things that we did talk about in previous modules. We know we see the y-intercept is 0, 0. There's a bunch of different x-intercepts through here. Bunch. And they happen at every integer multiple of pi. 1 pi, 2 pi, 3 pi, 4 pi for all of your x-intercepts. All right. Now, in the next 3, we're going to graph sine, but I want to use how this graph is going to be moving about the circle, and I want to specifically use the amplitude and the period. I don't want to plug in into a table of values. You could, but I don't want to. So the first thing I want to identify is the amplitude and the period. So I need amplitude and omega. So my amplitude is 2. My period, 2 pi over omega. So 2 pi over 2 is pi. With the period changing, this graph is actually going to be cycling faster. It's going to finish a full revolution quicker. So we've made the circle a lot small. Well, I don't want to say smaller because the radius is actually bigger, but the object is going to be moving faster. So I'm going to label my x-axis. Same thing, pi over 2, pi, 3 pi over 2, and 2 pi. I like to always go out to the 4th mark for 2 pi every single time. It doesn't matter what the radius is. It doesn't matter what the period is. And if I need to make my graph longer, so be it. All right. Now, I'm actually ready to graph this. Again, I'm going to use the movement of the circle. 1 full revolution is pi. 1 full revolution. So what this is saying, normally a circle would be 0 and 2 pi. In this case, it's going to be 0 to pi. So we're going to start at 0, so I'm going to put a point. We're going to start at 0, and we're going to end at pi. I want to get this first cycle drawn, the first cycle, before I do anything else. So I need my start and I need my end, which is what I have. So from here to here, it's going to have that motion. It's going to be done by then. So half of pi is pi over 2. So we're changing the look of this circle now. So pi over 2, what's its height? 0. What is half of pi over 2? Pi over 4. And that's when we meet our maximum radius, which is the amplitude. So it's in between. Now watch how I'm going to do this, please. It's in between 0 and 2 pi. It's in the middle. So I'm going to eyeball the middle, and I'm going to go up to my amplitude of 2. And then the bottom radius, what is in the middle of pi over 2 and pi? Whoops, 3 pi over 4. It's in the, just go to the middle. You don't even need to know what those numbers are. Find the middle of pi over 2 and pi. So I'm going to eyeball it, and that's the bottom of my circle. So we went up, back down, continued down, and then back around. This is one cycle. And it's going to keep going and going and going. So I want to see as many cycles as I have that I can fit from negative 2 pi to 2 pi. So I'm going to draw the next one. I got rid of that one because I had an arrow. I want to draw the next cycle. So it's going to follow the pattern. It goes up, down, down, back up. And now I want to go in the negative direction. Since this is odd, it is symmetric to the origin. So I just follow the symmetry. Keep this pattern going. You want to be careful that you didn't skip anything. This should be a very fast moving graph, you guys. It's cycling through a circle that's pi, not 2 pi. So again, it's moving fast. All right, so there's that one. Domain is still negative infinity to infinity. However, the range has changed. Right now, I'm not worried about you answering those questions. It's really right now, can we graph it? But you should by now. We're a Math 3 honors class. By now, we should be able to, on spot, oh, I just graphed this. What are all the features of this function? All right, let's move on. We're going to see something a lot different in this next one. I have a negative sign of 1/2 x. So your graph is actually going to do something different now. I still want to start by identifying the amplitude, which is +1 because that's your radius. The negative says your graph is going to go down first. Instead of starting in the positive direction, we're going to be going backwards around our circle in the negative direction. And then our period, here's omega, 2 pi over 1/2. This becomes 2 pi times 2 over 1, which is 4 pi. This graph is going to be very slow. It's going to take a lot longer for this object to complete one full revolution. I'm going to graph this using some shortcuts, you guys, and I'm not going to draw a circle this time. So you might want to make sure you write this down. Here's pi over 2, pi, 3 pi over 2, 2 pi. So I'm not going to keep filling everything in. I'm going to skip a spot, and then this would be 3 pi. Skip a spot, and I will have 4 pi. Skip a spot, and you have 5 pi. So you don't have to write it all in. All right, but I do have all of my marks. Now on the negative side, I'm just going to put the pi's. Okay. So I'm ready to start. There is, the y-intercept here is 0. There's no k, which I didn't talk about on the last one, but there's no k. So your graph is actually going to start at 0, 0. Now, the 4 pi, which is your period, that's the end. So what is halfway through this circle? All the way around is going to be 4 pi. All the way around. Half of 4 pi is 2 pi. So I have my beginning, my middle of the circle, and the end of the circle. Now I need to graph the amplitude. Now picture a circle in your head. The top of the circle happens halfway through, and the bottom of the circle happens halfway through. But keep in mind, this graph is actually starting in the downward direction. Oh, you know what? I'm just going to draw a circle for you guys again. It's fine. For a little bit, you might need this. Eventually, we need to not have to draw a circle. So we start at 0, and we end at 4 pi. So this is one full revolution of the object. We're going to start in the downward direction. So we have 4 areas that we're going to be graphing. I started by putting the end, so, well, the start, and then the end. So our start and our end. Then I put the middle. Halfway through is 2 pi. Now, what is halfway through 2 pi and 4 pi? Pi. But because we're starting in the downward direction first, this would actually be our negative part of the radius. So halfway through. So I want the middle of these 2 points. This is actually, I don't need to eyeball this. I can find the middle of those 2 points. I'm at pi. And because it's a -1, I go down first. Now I'm going to go halfway through 2 pi and 4 pi, which is 3 pi. And I'm going to go up here, because here's 3 pi, and that's at the top of the circle. Don't forget, we're going backwards, not what we're used to. We're going in the negative direction. So here's one cycle of negative sine of 1/2 x. You can see it's very slow. It's not happening very fast. Sometimes the longer ones are harder to draw. I'm going to draw a cycle on the negative side. So I'm going to put the points for 2 pi and 4 pi first. And then halfway through, it's going to be going up. Halfway through, it's going to be going down. So always think of the halves. Those are the easiest pieces to graph with sine. Halves. There we go. There's our sine graph. That is moving in the negative direction first, has a very slow period of 4 pi and an amplitude of 1. All right, last one. You're going to see something different here. When you're graphing a vertical shift, there are 2 ways that you guys can do this. I'm going to start with graphing the original graph first. Then you can go ahead and perform the phase shift of +2 so you can drag all the points up. Then I'm going to show you how to do this with actually moving the midline. And then you guys can choose from there which method you would like to use. So our amplitude is 3. Our period, our omega is 1. So 2 pi over 1 is 2 pi. Now you do have some questions like these on your worksheet with the sub that are just find the amplitude and the period. Go through, practice those. You should be fine with that. I'll talk to you about the middle section in a second when we're done with this, because you will have some questions where here's the graph, identify the amplitude and the period. So I want to discuss that a little bit with you, but I'll go back and do that with the other examples. So I have a normal period of 2 pi, so I'm going to put a mark, pi, mark, 2 pi. And then I'm going to put my negatives. Notice how I've made this coordinate plane very, very big. It's very, very big because I have an amplitude of 3 and I'm going to be shifting this graph up 2. So you're going to need a lot of room here. You always want to make sure you identify the amplitude and the period first before you guys start drawing your coordinate planes, just in case. All right, so I'm going to graph an amplitude of 3 and a period of 2. So my start is at 0. I'm going to graph the normal first, then I'm going to graph the +2. My period is 2 pi, so I'm going to end by 2 pi. Halfway through on the other side of the circle, we're back at 0. Halfway through, we're up 3. Halfway down 3. So we cut the circle in half and then we cut the circle in half again. Here's our first cycle. I'm going to copy this on the other side. Okay, now this isn't even my actual answer yet because now I have a +2. This thing right here says I have to take everything and move it up 2 because it's positive. If it was -2, I would move it down. So I'm going to grab all of these points that I just plotted and I'm going to move them all up 2. Using a different color would be helpful so you don't get points confused, especially if your graph overlaps any. Once you have all your points moved, sorry, that was a little bit like a V. It's really hard to draw these on the tablet. There we go. This is your answer. Okay, so that's graphing the original first and then doing a transformation. Now, what if I wanted to not have to do all of this work and I just wanted to plot some points and be done with it? So let me get all of that gone and let me start this over. So I'm going to put those back. Sorry, that mark didn't match up. All right. So now I'm going to pay attention to the plus 2. That plus 2, that's your new midline. That's your y-intercept. So instead of your y-intercept being at 0, 0, it is now at 0, 2. So I'm going to be up at 2. That's your midline. I'm going to draw a green dashed line through there. So I have my first point drawn. My period is 2 pi. So instead of putting the point on the x-axis, you actually put the point on the midline. Then you find the halfway point, put it on the midline. Then you go halfway through. Now here's the tricky part, because you don't go up 2, 3, you're going to go up 3 from the midline. So 1, 2, 3, halfway through, 1, 2, 3. Here's your first cycle. And then I can draw the rest. Follow the pattern, 2 pi, negative 2 pi, down 3, up 3. And if you miss a point on your graph, it's really noticeable because the symmetry here. Fix it, just erase it and fix it. It's not a big deal. All right, one more thing that I do want to talk to you guys about is how do you find the amplitude and the period from a graph? So let's say, let me draw a quick one for you guys. I should have had this ready already, but I forgot that I needed to talk to you about this. So I have a quick graph drawn here. And let's say that this is all filled in. Okay. And let's say the graph looks like this. And it's going to keep going and going, drops down, comes up. Okay, amplitude is easy to find. So the amplitude, easy, just pay attention to the scaling. What if the scaling was 2, 4, 6? So you might think it's 3, but it's really 6. So pay attention to that. Now for the period, this actually should not be that bad. Know that a cycle of sine has to be 1 full revolution of a circle. So you start up, go all the way down to the bottom, and then back up to 0. That's 1 cycle. Or if it's a negative, it'll start down, go back up to the top, and then back to the middle. So you're looking for that. So here's my center, my 0. It goes up, all the way down to the bottom, and then back up. So in this case, the graph has a period of pi with an amplitude of 3. So take your time on those. I didn't give you too many of those on the worksheet. Watch this again if you need to, and then when I get back on Wednesday, I'll be answering any questions that you're not able to. Do what you can. You're turning this into the sub, the work for tomorrow, or if you're watching this on Tuesday, then today. You're turning it in, and then you guys can continue working on 6-1 through 6-4, so you're ready for a quiz on Thursday. But also be ready with questions on Wednesday. Wednesday will be a question day. And I'll see you on Wednesday. Bye.